All right, we're on page 21 of our notes and still working on samples, collecting samples on observational studies. And we're going to talk about the cluster sample. The cluster sample is kind of a cool idea because we said that a good sample looks like the population. Well, cluster sample means in a cluster sample, we've divided the population into little groups, and every single little group looks like the population. I'm like, that's a really good start place to begin. So every cluster is a microcosm of the population. Every group looks like, every little cluster looks like the population. In other words, every little group has the elements of the population contained in it. In a cluster sample, I have all these clusters that look like the population, and I randomly select one of the clusters. I may select more than one, but I randomly select at least one of the clusters. And once I collect that cluster, I survey everything within the cluster. In other words, I randomly select a cluster or clusters, and then I perform a census of that cluster. So if my cluster had 50 elements in it, then I would survey all 50. So I was like, okay, we had millions of clusters. We randomly selected 3. Each cluster had 50 elements in it. I selected all 50 in each one of them, okay? So we randomly select the cluster, but then we randomly select the cluster, and then we survey everything in it. That's what a cluster sample is. So when is it useful? Because sometimes this one is a little bit difficult to think about when you might do this. First off, drawing blood. I want to know what the blood in your body looks like, whether it's healthy or not, and they do that all the time. That little sample is a cluster because it represents the entire, I mean, they could draw little samples all the time, and that little sample of blood that they drew is a cluster. And matter of fact, they even break that cluster down smaller when they look at it under the microscope. And in that little section that they look under the microscope, they see the red blood cells, the white blood cells, the platelets, the plasma, the whether you have healthy things or sick things. And they say that that represents your entire body. So very useful in the medical field. You yourselves have also probably conducted a cluster sample, or at least worked with one of your parents or grandparents with them. Because if you've ever made cookies or cakes or brownies or icing or gravy or soup or other sauces, chances are you put a bunch of ingredients into a bowl and mixed, and then you took a spoonful. That spoon is a cluster in that it has, if it was the brownie mix, it has chocolate, it has flour, it has sugar, it has butter, it has oil, it has everything in that one taste, and you taste that one thing and it represents the entire population and lets you know whether it tastes good. All right? So the next one, and I like to go to I call this my Forrest Gump example, because I think this life is like a box of chocolates. I think this is one of the best examples to think about. So every Russell Stover's chocolate truffles is the same, or essentially the same. They have exactly the same type of truffles in there. In fact, they're in the same order. All right, they're the same location in a box. So if I go to the store and I want to know whether or not the Russell Stover's truffles are good, what I would do is I'd say every single box that they manufactured represents a cluster, because they all have the same thing. They all represent the population of Russell Stover's chocolate truffles. So I might take a box. If I wanted to do a cluster sample, I would take a box randomly. That random selection means I randomly selected one of the clusters. I randomly selected a group, and that group represented the population. And then I need to perform a census, which means I would need to eat every single one of them. Okay? That would tell me whether or not it was representative of the population. So a cluster sample is I randomly select something. I randomly select a group. The groups all need to look like the population. And when I randomly select the group and it looks like the population, then I perform a census of it. I will tell you this, cluster samples don't work very well for human data. They work great for manufacturing, they work great in medicine, they work great in cooking or baking, but they don't work very well for human data, and here's why. How do you divide up a group that looks like the population? When we divide up the nation into states, no state represents the other states because we all have different characteristics. So those are not good clusters. And we say, hey, what about the city of San Antonio? Well, you can divide it a few different ways, north, east, south, and west. And quite frankly, neither group looks the same. I break it up by zip code. And if I break it up by zip code, yes, I have clusters, but the clusters don't look the same. I mean, think of it this way. What other zip code besides 78258 has Stone Oak Palms represented? And there isn't one. So basically, the clusters don't look alike, so therefore they don't look like the population. So very, very, very difficult to do with human data, but it's great to do in manufacturing where I have a box of the same components or cars, et cetera. And it's like, hey, the car represents a cluster because it has all the different parts. We test the car out. We say the car works great. That means all the components that we've been buying from to put the car together work. Okay, so a cluster looks like the population. We randomly select the cluster or the small group, which is the cluster, and then we survey everything within it.